All right, so I'm going to breeze through this because this is a little bit of a longer talk. Really what I'm going to try to cover today is a synopsis of what the latest developments are in the VAD industry. As a matter of disclaimer, I do own stock in both Medtronic and Abbott, and I plan to own a whole lot more. So there's going to be 6 or so parts to this talk. First, I'm going to talk about some of the major changes in the industry itself. Then we're going to talk about VAD-related complications. Focus of this presentation is going to be on pump thrombosis, what we know about it now, and where are we headed. We want to know whether pump thrombosis can be made better. Can pump thrombosis be eliminated with new technology? And where do VADs go from here? So first of all, there's been a number of acquisitions in recent years for those who haven't been following. We started out with 2 companies with approved devices, Heartmate and Thoratec, each about $1 to $2 billion in capitalization. St. Jude bought out Thoratec in 2015, and it itself has about 12 or 13 times the capitalization. This was very good for the VAD industry. In a similar fashion, Medtronic, with $106 billion capitalization, bought out Heartmate, and finally Abbott bought up St. Jude. That's where we are right now. We've got 2 big companies that have ample cash flow to be able to push things forward. In terms of the regulatory status, we haven't gotten very far in the last couple of years. For bridge to transplant, we've got 2 devices, and for destination therapy, still only 1. We've got trials that are ongoing and wrapping up. When I teach my residents, they always like to have a mnemonic for trying to remember things when they're being drilled, and I try to make it a little bit colorful for them. So the VAD-related complications go by the mnemonic of BASTARD. Bleeding early, aortic insufficiency, stroke, thrombosis, angiodysplasia, RV dysfunction, and driveline infection. A couple of years back, I wrote a review of where things were back in 2014. And at that point in time, everybody was worried because we had a whole series of articles that came out demonstrating the same thing, namely that the VAD thrombosis rates were going up. The sites of thrombus formation can be variable. This is not to be considered complete, but it's either going to come proximal to the pump and embolize, it's going to be formed de novo in the pump, or it's going to be propagating backwards from clot in the outflow tract or problem with the outflow anastomosis. You can see here evidence on the right of a thrombus on the VAD itself. In the Heartmate II device, most of the thrombus is forming at the pivot point between the stator and the rotor itself. We have to be very careful when reviewing the literature on VAD thrombosis because the studies tend to conflate a number of the terms. So when you're reading it and trying to compare, you want to differentiate between suspected pump thrombosis, which includes both confirmed and unconfirmed cases. And the way to remember this is the confirmed is when somebody actually got visualization of a thrombus in a pump. So basically the patient underwent heart transplantation with the pump excised, or the pump was removed and exchanged, or the patient died and the pump was evaluated. We also want to be careful of how we look at incidence. Incidence can be done as a reflection of per unit time, and we can also talk about events per patient year. You want to keep those straight as well. You don't want to compare incidence with events per patient year. The way we figure out events per patient year, it's actually quite straightforward, but most are confused by it. In the denominator, we have the number of patients in the study times the number of years each patient has been in the study or has had a device till the end point. And as a numerator, the number of patients that had the event. And that's events per patient year. It basically standardized for the time when you have patients who've had variable periods of follow-up. Before 2012 or so, the VAD thrombosis rates were relatively low. We had events per patient year of less than 0.03, and at 2 years' time, less than 4% of patients had experienced the VAD thrombosis. This was our baseline. This is what we had been used to with the continuous flow pumps. Then, in 2014, several articles came out, one on the HVAD, and all of them showed alarming rates of VAD thrombosis. Here we see in this picture 2 generations of the HVAD pump, or 2 permutations of it. The one on the left is no longer used. It was essentially bare metal, bare titanium, and the one on the right is sintered. The change was made because on patients whose hearts were excised, we found that with the patients who had the bare titanium, there was thrombus encroaching on towards the orifice of the pump, whereas those with sintered titanium with the fibrous ingrowth of tissue were prevented from having it. In the HVAD study, they found several things were predictive of whether a patient developed pump thrombosis. Whether they were on no aspirin, their INRs were subtherapeutic, the patients were less ill, so they actually had higher intermax profile, and the patients who had higher blood pressures. The last one with the supposition that that was reflective of less flow through the pump. You can see the odds ratios there. As a result, the study had been modified, and wherever they could, patients were placed on at least 162 milligrams of aspirin, placed on higher INR targets, and shot for a lower mean arterial pressure. At the same time that study came out, the New England Journal of Medicine Heartmate II study came out of 3 major centers, Cleveland Clinic, Barnes-Jewish, and Duke. And as you can see in this diagram, on the x-axis is the year, on the y-axis is devices with confirmed pump thrombosis. And you can see around 2011, 2012, there was a huge uptick. And it was parallel for each of the institutions. Also importantly, before 2011, the average time it took for a patient to develop a pump thrombosis was 19 months, whereas after it was less than 3 months. Clearly something was going on, and to confirm this, Intermax reported its data and showed a 6-fold increase in the pump thrombosis rate over about 4 or 5 years. So, in 2014, for both the Heartmate II and the HVAD, pump thrombosis became a catastrophic issue that emerged in 2011 and was widely reported in 2014. Consequentially and predictably, there were sequelae for the industry. Number 1, FDA warnings were issued for both devices. Number 2 was an abandonment of the Revive It trial. Revive It was a trial to look at extending VAD therapy for the less ill population, first with the HVAD, and then it was changed over to with the plan of doing it on the Heartmate II. Initially, the Revive It was abandoned with the HVAD because of a high CVA rate. And ultimately, the Heartmate II was abandoned as well because of the high pump thrombosis rate. The consensus at that time is we really got to figure out what's going on with the pump thrombosis before we try to extend this therapy any further. So the question becomes, with the present technology, can pump thrombosis be ameliorated? First, obviously, is the challenge of knowing why it happened. And there were many theories. There was no plausible single hypothesis. The issues that had been felt to be important was the adoption of a lower anticoagulation target when we initially saw high rates of bleeding after VAD surgery. So surgeons became much more liberal in how low of an INR they would tolerate. And heparin bridging was also stopped at many centers. Blood pressure wasn't closely controlled. There were some mechanical issues with the pump position. And many of us were lowering pump speeds to try to avoid some of the complications we discussed. I like to say that there's a yin-yang of pump speed. You know, at the lower pump speeds, you have a lesser likelihood of a suction event. You have a lesser likelihood of RV dysfunction. You have greater systemic pulsatility. more aortic valve opening, possibly contributing to less AI, lower GI bleeding, and less LV stasis. With higher pump speed, on the other hand, you have greater effective cardiac output and better washout of the device itself. And the question is, how do you balance everything? Many of us were down titrating the LVAD pumps, particularly early postoperatively, to try to avoid some of the early sequelae, especially suctioning. So a trial was initiated, run by Thoratec, of seeing if they could come up with a single protocol and have everybody in the study follow this protocol and see what we could do about the VAD thrombosis rate. So the protocol addressed surgical technique, pump speed, anticoagulation, and blood pressure. The comparison group was the established rate of 8.4% pump thrombosis rate in that New England Journal of Medicine study. So the goal was to see if we could do any better. There was a protocol, which I'm not going to belabor, but it was the consensus best evidence for the group. Interestingly, there were expectations about, as you all know who are in the VAD care arena, many patients don't allow themselves to be treated optimally. The expectations regarding adherence was that everybody would put their best effort. Please adhere if you can. The targets to evaluate, the primary endpoint was how many patients had confirmed pump thrombosis at 3 months. This is a summary of the study. I won't belabor the point. What they found was that there was a confirmed pump thrombosis rate of 3% at 3 months versus the 8.4 historic control. So a big difference. Adherence was a problem. So we like to say it's like herding cats. Most of the issue, of course, was clinicians were making their best efforts. It's just that the patients weren't obeying, meaning that they weren't behaving as they should. You can see here that 78% of the patients, the surgical recs were followed, 95% had heparin bridging, the Coumadin was therapeutic at 100%, aspirin 82%, and pump speeds, the higher pump speeds were maintained, at least for the most part, above 8,600. But as we all know, that's the lower part of the spectrum. And MAPs were kept below 90. Overall, there was good adherence, meaning following most of these in only a little bit over half the patients. Importantly, at 6 months, if there was good adherence, the pump thrombosis rate was less than 2%, but if it was anything less than good, it was up at 9%, pretty much the same as we found historically. The endurance trial for the HVAD was to evaluate its long-term efficacy for destination therapy. And I'm not going to go over the whole trial, but I want to point out that with these modifications in patient care that the HVAD patients underwent, you can see in comparison between the Heartmate II and Heartware. Heartware is on the left, the Heartmate II is on the right. And you can see that the pump thrombosis rate was 8.8% at 2 years versus 16.2% with the Heartmate II. So in summary, we can make it better, but there's a limitation. With the HVAD, anticoagulation, aspirin dose, and close titration of the mean arterial pressure can lower the rates. And with the Heartmate II, you can see the 4 criteria that we just discussed. The problem is this good enough? And is this satisfactory? And can we confidently move on from there? Especially when, even within the context of a trial, adherence was not great. How about one of the last topics? Can pump thrombosis be eliminated with new technology? Well, for those who have been following what's been going on with the LVAD industry, recently it was published on the maglev technology for the Heartmate III, where the Heartmate III was compared to the Heartmate II. On the left is your conventional Heartmate II, on the right, the Heartmate III. It's got a number of design advances that I'm not going to belabor, but a lot of elements to it that would indicate that it should be less prone towards VAD thrombosis. European CE mark study took a look at the Heartmate III, enrolling 50 patients in a prospective multi-center study with only one arm. Importantly, there were no patients that had pump thrombosis or VAD replacement. This is the follow-up presentation at a year's time, and again, there was still no significant hemolysis, pump thrombosis, or pump malfunction at 1 year. Now we're going to move to the Heartmate III Momentum 3 trial in the US that compared the Heartmate II to the Heartmate III. Randomized the patient in 2-to-1 ratio. The composite endpoint was 6-month survival free of either disabling stroke or reoperation to replace or remove the LVAD. So you can see that the main morbidity this study focused on is formation of clot. Baseline characteristics were the same. The endpoints. This was a non-inferiority study. Despite that fact, both the non-inferiority analysis as well as the superiority analysis showed that the Heartmate III was superior to Heartmate II. Major adverse events, you can see that the pump thrombosis rate was 0. All the other outcomes, there was no significant difference. So, with improved survival and otherwise comparable adverse events, the Heartmate III practically eliminates the pump thrombosis problem, at least as far as we can tell from the study. The question remains, if and when Heartmate III is approved in the US, why would you ever put any other device that's presently on the market? Here's a summary of the data that I showed you, and you can see down at post-2013. Well, let's look. Heartmate II, 0.07 is the events per patient year. HVAD, 0.03 to 0.06. Heartmate is 0. Where do we go from here? So we talk about the morbidities. Bleeding. Many centers have started to use thromboelastogram, modifying technique. Jury is still out. And now that we're starting to be more aggressive with anticoagulation, we have to keep a lookout that we're not going to have a recurrence of the high bleeding rates we used to see. AI, refinement of the RPM algorithm. And in those patients that do develop AI, instead of undergoing a surgical procedure, some of them may be candidates for off-label TAVR. Stroke. If we decrease the pump thrombosis rate, hopefully the stroke rate will decrease as well. However, we have not seen evidence of that to date, and the Heartmate III arm had similar stroke rates to the Heartmate II in the study. Thrombosis, have we eliminated with the Heartmate III? Time will tell. Angiodysplasia, if we decrease the AI, we'll decrease the angiodysplasia and the bleeding. RV dysfunction, we're still way behind on this one. Optimal screening and timing is very important for these patients. Echo techniques are still being refined of what can be the most valuable information, but one thing that really helps is now having the Impella RP device to help us with patients and make the decision easier to support the right ventricle. And driveline infection, pretty much for the foreseeable future, is trying to eliminate it to solve it. Those are just reiterations of the summary. Thank you very much.